Hello students, today we will study about the solving the equations which has one side linear expression and another side number of the equation. This is the topic of standard 8 chapter number 2 linear equations in one variables. Okay. So in previous class we have studied about the introduction of the chapter. So in that class we have studied about that linear equations are such equations in which the power of the variable is 1 and also the variable is also 1 in the equation. So there are some classifications between the linear equations. So first part of that classification is equations in which one side there are some linear expression and another side, right hand side, there is some kind of number. The second type of classification is both the side there are linear equations. So first of all, in today's class we will study about the equations in which right hand side, left hand side there are linear expression and right hand side some of the number is there. So first example here is find the solution of 2x minus 3 is equals to 7. Right? So this is a linear equation with variable x. Right? So what we have to find? We have to find the value of x such that this left hand side value becomes the equal to the right hand side value. What is the right hand side value is 7. So what value we can put instead of x such that this value becomes the 7. To find out this solution, what we have to do is there are some steps. First step is to see we need only the value of x. So all other terms we have to either to subtract or to add or to divide. So first thing we have to do is there is a minus 3 with 2x. So if we add plus 3 here, what will happen? This minus 3 and plus 3 becomes 0. So minus 3 we can remove in this way. So that is the first step. Add 3 to both the sides. Notice that here we have to add 3 to the both the side of the equations. Why? Because we have to balance the equation. If we only add 3 to the left hand side, it will not become the balanced equation. So to make the balanced equation, we have to make same process both the side. That I have said earlier. So first step is to add 3 to the both the side. What will happen if we add plus 3 to the left hand side and plus 3 to the right hand side? So the value here we get is 2x, this minus 3 and plus 3 becomes 0. So left hand side there is 2x is remains, right? And what will we get right hand side? 7 plus 3 is 10, right? So the equation we get here is 2x is equals to 10. Now here there is a 2 in the multiplication of x. We want to find out the value of x only. So what we have to do is we have to divide this with 2. But we cannot divide only left hand side. We have to divide both the side. So divide both side by 2. Now what will happen? We will get left hand side 2x upon 2 and right hand side 10 upon 2. Now this 2 and 2 will cancel out. Only x is remain to the left hand side and 2 5s are 10. By cancel out the common factor, we will get right hand side as 5. So the value of variable we get here is x is equals to 5. And this is the required solution. So by putting this x in place of here, we will get this left hand side value is equals to 7. To verify this, let us put this value. So the left hand side is 2x minus 3. Yes. 2 remains as it is. Instead of x, we have to put 5. Minus 3 remains as it is. 5 2s are 10. 10 minus 3. And what is 10 minus 3? 10 minus 3 is 7. And see here, 7 is there. Yes. And that is our right hand side part. So left hand side part is equal to the right hand side part. So that means our solution is correct. Right? So do you think that any other value of x we can find such that this equation remains balanced. Think about it. Okay. Okay. So now we will study one of the example, that is solve the equation x upon 3 plus 5 upon 2 is equals to minus 3 upon 2. Right. So what we have to find out the value of x such that this value of left hand side becomes equal to the value of the right hand side. So what we have to do, take this term to the right hand side, or in first sum what we have to do, whatever is here we add the 3. Whenever there is minus 3 we add the plus 3 such that the total value becomes 0. So here what we have to do, take this 5 by 2 to the left hand side. This also we can do, right? So transporting 5 by 2 to the right hand side, what will become, x upon 3 is equals to minus 3 upon 2 remains as it is. This term 5 upon 2 as go to the right hand side, its sign will be changed, minus 5 upon 2. So what basically we do, we basically subtract 5 upon 2 from both the sides. So by subtracting 5 by 2 here, this plus 5 by 2 and minus 5 by 2 becomes 0. And here we get the minus 5 by 2. So in this way, we just by not showing that we are subtracting 5 by 2, we can do this step by taking this 5 by 2 to the right hand side. Okay. Now left hand side there is x upon 3. Here 2 is the LCM. Minus 3 and minus 5 remains as it is because we don't have to multiply any number because there are 2 in both the denominator. Now this minus 5 and minus 3 becomes minus 8. By cancelling the common factor, what we will get, 2 4 the 8 minus 4, and here there is x upon 3. Now we want to find out the value of x. We have to take this 3 to the right hand side. So what we have to do, multiplying both the side by 3. If we multiply this side with 3, what will happen? 3 and 3 will cancel out. Only x is remain, and right hand side by multiplying 3 we get minus 12. And this is the solution. To check that our solution is correct or not, put the value of x here to the left hand side. So here left hand side is, instead of x, minus 12 is there. Minus 12 upon 3 plus 5 upon 2 remains as it is. Now simplify this. 3 4s are 12, we will get minus 4 plus 5 upon 2 as it is. We have to 2 take as an LCM. Multiply this 4 with 2, we will get minus 8 plus 5 upon 2. Minus 8 plus 5 gives us minus 3. 2 remains as it is. So answer we get is minus 3 upon 2, and see here. What is minus 3 upon 2 is the right hand side. So our left hand side value becomes equal to the right hand side. That is why our solution is correct. Okay. So in this way we can solve the linear equations in one variables. Okay. This is all about this lecture. Okay. Thank you.